I hope you'll appreciate that we will not give away the complete modeling sequence of this competition model. Let me refrain by just giving you some hints and tips in modeling, in how to define points and constraints and how to define certain methods. Again, first thing is start simple. So first thing you should do, in my opinion, is lock the base part to the ground. Don't model the contacts yet, they're too complicated and will mess up your response. So first create a lock joint between the base and the ground, fixing the base to ground, so now you can focus on the top part there. Simple idea of the joints. We want the slewing pivot to rotate about the vertical axis, so you need a joint, the slew joint as it is here, between those two parts, and you will need a motion to drive that slew joint. Same thing for the connection between the boom and the slew pivot. You need a revolute joint there connecting those two parts together, and you need a motion to drive this angle. Just giving you an idea of a sample motion, in this model I have used design variables to make it better. Using design variables, I think, is above the scope for you, but it gives you an idea how you can work in Atoms. You can ask for the information on this motion and you'll see the formula. This is, well, you could call this a quite complicated formula. In this formula I'm using a step function, so I'm actually using a step function plus another step function to get a ramp up and a ramp down. The step function, as you will realize, is a function that allows you to define a transient between two base values. From this motion dialog we can go to the function builder, and then we can actually ask for a plot of this motion input. You see, I've been actually playing around with defining a sinusoidal disturbance to see what happens if we disturb the input. So this is like a test model that I made to test different situations. The most complicated part of this model actually will be in the fixing of the clamp to the boom, and moreover the clamp to the load. Just showing some other details. The connection between the load and the buckets. Well, you can think about it a long time, but the most easiest way to do that is just by defining a contact, a sphere to sphere contact between that load shape and each of these spheres on the ground. So you have to find 3 contacts in the start point, 3 contacts in the target point, and use that to keep the load in the buckets. A good advice here is to start using design variables. If you define all 6 contacts using the same design variables, it's very easy to change it, and it's much more supported to do design studies using that approach.